We're live, my friends. We are live. Stream on in, stream on in. Let me get this going on the arena as well. We're gonna get that started as well. Boom, boom, boom. We are live, my friends. Let's go. I'm gonna let the folks stream on in, my friends. I'm also going to mute this so that this does not destroy this. As soon as I figure out where that mute button is, boom. Let's go. All right, my friends, let's get this thing started. I'm going to start this off by just a quick summary of how we're going to go about things today, because we're diving into AvaCloud, and you already know AvaCloud is pushing the boundaries of privacy in Web3 for developers, enterprises, as well as innovators alike. While transparency has long been a cornerstone of blockchain, there's a growing demand for privacy. So, especially in institutional enterprise settings, that's where the new EERC standard comes in. And that's what we're going to explore today. We'll explore how AvaCloud is championing compliant, privacy preserving tools while also staying true to their transparent, community driven roots. And we'll also talk about some real world use cases, break down what makes EERC make so timely, as well as spotlight the people making it happen. Today, I'm your host. My name is Breevy, and I'm joined by some absolute stars, my friends. We have our friend Firkin Boyraz here of the privacy team over at AvaCloud. Say what's up, my friend.
Oh yeah, hello everyone. So I am Furkan, and I am currently working on the AvaCloud privacy side for the past 8 months. I'm super thrilled, actually, super excited to be here right now.
Hey, we're super excited to have you, my friend. Thank you so much for popping on today. We're also joined by Mehmet Osterk, also on the privacy team over at AvaCloud. Say what's up, my friend.
Hey everyone, I'm Mehmet. I'm one of the developers on the privacy team as well. I am one of the main contributor of the ERC. I'm so excited to be here.
Hey, and again, man, we're excited to have you folks here, man. We had a very, very interesting conversation to have, and I know all the folks out there are extremely excited to hear what we have to discuss today. And of course, last but certainly not least, we have our friend here, Will Waltrip, Director of Product over at AvaCloud. Say what's up, my friend.
Hey everyone, Will Waltrip. I think you may have heard from me last week, and I'm back again. Really excited for this one. You get to meet some of the big brains that I'm privileged to work with, and hear more about some of the stuff we're cooking up on the AvaCloud side.
Dude, so excited to hear about everything that you folks are cooking because y'all been cooking, my friend. Y'all have been cooking because I had you folks on maybe like 3 4 weeks ago, and now we're back with a brand new innovation already within a month. This is insane. But just for a refresher for folks who might not have checked out our first live stream, can you give folks just an overview of what you built over at AvaCloud, and then we'll kind of flow on from there.
Yeah, so AvaCloud, we've been around now for a bit over a year and a half or so. Our primary objective has been making blockchain adoption and building relevant real world applications much easier on a blockchain. So that started off with how do we drive the adoption of Avalanche L1s. And then we've extended it into other applications and tooling that really make it much easier once you've got your L1 up, and you can speed up that time to market. So that comes with interoperability tooling, gas relayer. We announced EERC a few weeks ago, which is part of why everyone's here today. We've got a few other things coming up, but super excited.
So very, very excited to talk to you folks about this. For everyone out there, introducing the EERC, that token standard for privacy specifically. Before we start diving into that, I wanted to bring up Etherpay. If you can kind of just give me a brief summary of like how that kind of came about?
Yeah, I can take that. So we founded EtraPay back in 2022. So it was based in Istanbul, Turkey, and so we were designing a global payments chain with various novel technologies incorporated directly to the chain itself. So when we were so as the name suggests, to start with, the EtraPay stands for electronic transfer and payment. So the idea was like how to revolutionize payments with blockchain capabilities of the blockchains. Then we realized that there's a problem, there's an existing problem with the blockchain systems, which are generally stem from the lack of privacy. So we kind of shifted towards to solving them first, then focusing back on the payment side. But now most of our product suite is it consists of privacy solutions, basically.
I see. I see. Thank you for that. I was like really curious, and since you talked about kind of privacy solutions as well, obviously this is what we're all here for. I don't want to tease the folks out there too much. Um, can you talk a little bit about why these kind of privacy products are getting a little bit more attention today? You know, kind of because historically we kind of think about Web3, it's all about transparency and all that kind of fun stuff. But why is the privacy side of things getting so much attention now?
Yeah, so Avalanche is unique in the fact that it offers these various highly configurable L1s, right? So you can have a totally permissionless public network, but you can also have a private permission chain, which means that, hey, I can launch my L1, I can have an allow list of nodes that are able to sync the data, and I can get even more granular with saying, okay, only certain addresses can submit transactions, only certain addresses can deploy contracts. So that's pretty powerful on its own because it enables enterprises and institutions who are maybe sensitive around what public community members can access their chain data. But even within those institutions, all of the data is public. So if anyone who you give access to your chain, all of the data is still public. Anyone who can go in there can read the data and kind of see what's going on. So it introduces this problem, particularly when you start to talk about institutional adoption and kind of growing, investor adoption and things like this, because all of a sudden, if I'm buying and selling trading assets, right, all of my transactions are public. You can see my portfolio. It means people can front run my transactions. It introduces the risk of price runs on tokens. So it starts, we see this opportunity of, well, by introducing these privacy preserving tools, we can start to engage this market of users that previously were not able to adopt blockchain technology and still leverage the public network of the liquidity that Avalanche offers, right, from the C chain. So it becomes quite a powerful driver of blockchain adoption and kind of bringing about greater efficiencies for these businesses who are deploying on L1s.
So what I'm hearing is this is extremely important, specifically on the kind of more institutional enterprise side of things. Um, Specifically with the institutions, it seems like they kind of want to keep things a little bit more private for their clientele. Can we talk a little bit about how these privacy preserving features that you've developed so far kind of differ from kind of the ones that are kind of previously released, I should say?
Yeah. So I think and we'll dig in to actually draw some comparisons when we dig in on EERC specifically. I think historically, and why we like to make this distinction is historically privacy preserving tools on blockchains kind of have this negative association. Hey, they're used by bad actors, they're used just for malicious behavior. We're really trying to change the narrative a little bit to start to show, hey, we offer the controls needed so that projects can have full auditability. It means that you can stay regulatory compliant, and you can still benefit from some of these components that we're offering, right? And I know I highlighted institutional use cases before, but this makes it really appealing for, like, let's say you're a gaming company who wants to tokenize in-game assets that and balances that users hold, right? Now you can do that, and now me as a user who holds some amount of in-game dollars, I don't have to have all of that public, right? Which is a huge benefit, especially when you think about the tangible value of a lot of these assets in games these days.
I actually really, really like that, because that was one of the things when I first got into Web3. Like, I kind of couldn't wrap my head around. Oh, everyone's going to be able to see how much money I have. That's interesting.
I mean, my favorite use case, and Furkan and Barat and Matt have kind of heard me go on about this, is I come from a payments background. I used to work at a bank that did supported third-party payment providers. So that's payroll companies, property management companies, things like this, and they're taking large-scale payments, and huge opportunity for blockchain, right? Lots of efficiencies that you can bring on chain, but obviously, like, if your employer said, "Hey, we can issue you payroll on the blockchain," you'd probably be a little apprehensive, because you're like, "Oh no, like, someone can see how much I'm getting paid each week," all of these things, right?
Exactly.
The innovations that this team has produced, like, offers this opportunity of, hey, now we can bring some of these real valuable, tangible, addressable use cases on chain, and they can actually realize some of the benefits. So yeah, pretty excited about that.
I really, really love that example, because I was thinking about that the other day as a case for one of my friends. I was telling them, man, like, Avalanche came out with this new Octane upgrade. Fees are impossibly low, like, just pretty much like irrelevant at this point. um, like, you should really think about, thinking about paying your staff or your independent contractors in tokens or on the blockchain. Um, it's like super easy now. Obviously, like, there's UX issues and all that kind of fun stuff, but as far as paying less money for this specific use case, I think every business kind of can benefit specifically from this.
Yeah, you let your friend know. I'll talk to him. We can build a prototype out and see if we can help him out.
Boom, there it is right there. There it is right there. I appreciate you, Will. And since we're kind of talking about, like, timing of things, like, can you kind of talk a little bit about why this kind of introduction to EERC is, like, why right now? Like, why is this the best time for it?
I think it's actually quite timely, given in the U.S., like, there's been a significant administration change, and a lot of that has changed the position towards crypto and blockchain regulation. And so I think now, kind of releasing these sort of features and solutions, it really aligns with some of the general market sentiment around, hey, more things can go onto the blockchain. There's less of this kind of regulatory compliance ambiguity. And so it means that some of these target audiences, like institutions or even large games, have regulatory and compliance concerns around these sort of things.
Yeah.
It's a lot more feasible, a lot, they're definitely more interested, and not likely to just do a proof of concept, likely to take the next subsequent steps.
And before we kind of get, because I do want to talk to Furkan and Mehmet, kind of give, like, a high level on, like, the technology that's kind of used behind the scenes. I really want to spotlight something really, really quick, and you stop me if I'm wrong, Will. Prior to AvaCloud, an institution would have to build out this tooling themselves.
Yeah, so I mean, institutions would need to have kind of this level of skill set that Furkan and Mehmet bring to the table.
Yeah.
They would also need to have some of the knowledge of maintaining and managing a blockchain. And then typically they would also do that in a totally separate environment, right? Like you don't benefit from the liquidity that's already on the C chain or the other, interoperable use cases. So I think that's the key thing to highlight there.
I appreciate you for highlighting that too. I have to make sure that the audience out there knows that because it's extremely, extremely important, especially when you're thinking on the institutional side where these guys kind of stuff. Now, Furkan, Mamek, can we talk a little bit, just high level, high level, high level? I'm not a genius like you folks. On the technical side, behind the scenes, can you tell me a little bit?
Yeah. So as a high level, the EERC is basically an ERC20 token standard with extended capability of hiding the balances stored in the smart contract and the transferred amounts between the two users. So this is what we call or refer as confidentiality. If the protocol were to be anonymous, then it will mean that we are hiding the addresses that are interacting with the blockchain, but we are not. So the EERC focuses on confidentiality, which in short, hiding the values in the transactions. It is directly suitable for payments, but it can be possibly extended for other use cases with, of course, like a given skill set. Like you maybe need to write some custom circuits, but what I'm saying is, if you want to build something like that doesn't offered by the current EERC standard. So one of the main component is the auditability module, which Berat will talk about it in detail. But it's basically to ensure compliance without actually leaking any details to the public.
I see.
I hope this suffices. Yeah.
Oh, sorry, Mehmet, you just unmuted. You got it, my friend.
Yeah, I'm just continuing with some of the unique components that ERC put on the table. Is actually, like my Furkan said, is the auditor module is the unique aspect of the ERC, which is actually in the contract, on the ERC contract, there is a auditor public key, and in the protocol in the ERC, when you are doing a transaction or registering to the protocol or sending some encrypted tokens to another user, this zero knowledge proofs circuits will enforce you to encrypt the transaction details alongside with this auditor public key. So with that, which with this enables us to auditor at the later time can decrypt the previous transaction and see the transaction details. Actually, this is very important to real world adoption for the governmental use cases, governmental institution for the blockchain's adoption. And there's actual additional point that I need to make up, but it's going to be a little bit technical, but I try to make it simple as possible. So in ERC, we are storing users' balances in two different ciphertexts, maybe. One of them is the Elgamal ciphertext, which is a elliptic curve cryptography. It's just a point on the coordinate system. And the other one is the Poseidon, is the one of the popular hash in the zero knowledge area. Poseidon hash-based encryption scheme. These are the two types of the user's balance in the ERC. So what makes ERC unique is all of the balance is encrypted with this Elgamal ciphertext. So it's actually is a point on the coordinate system. But when you are trying to decrypt this ciphertext with the user's public key, it's resulting in a different public key in the curve, which is hard to get the scalar value of that point. You need to solve a discrete logarithm problem. It means that you need to break the whole elliptic curve cryptography. Because of you need to do a high computation to get the scalar from them. What ERC actually puts the table is actually we are encrypting the balance and the user's transaction amount with the different kind of a ciphertext as well, which I already mentioned is Poseidon-based ciphertext. So which enables, I'm just, instead of doing this, solving the discrete logarithm problem, we are just decrypting on the locally, and we can get the resulting value very easy without doing a heavy computation. This makes ERC very unique and very powerful too.
Yeah, I mean, to continue from there, actually there was a well-known protocols that like previously offered confidentiality. One of them was called Zither, which is like well known by the privacy community, blockchain privacy community, and it also offered confidentiality, and it used also like Elgamal, elliptic curve based Elgamal ciphertext. But the problem with that is the size of the value that you can encrypt, right? Like, you know, in ERC20s, generally, like we are working with UN256, right? This is super incompatible with that ciphertext, like the encryption scheme actually. Because while encrypting, you need to map, you're actually not encrypting the value directly, you're encrypting a point in the curve. I know this is going like a bit too technical, but just to provide a side note here, this is we did this to eliminate this problem of like decrypting value, like decryption were taking too long basically in the previous protocols. Now it's basically instant, and you can encrypt super large values up to actually like 254 bits. In previously, this was limited to 32 bits. Like there were some workarounds, but this is like what we're doing here is actually super efficient. Not in terms of the like decryption time, etc., but also in terms of the gas cost on chain. So also like we can continue from there. Actually, one of the problems that ERC solves is the front running issue. So that's a bit of an interesting thing. Actually, it doesn't like directly refer to the front running that we are all used to in DeFi. So let me try to explain. So this doesn't exist with regular public tokens, basically. So let's say there's an Alice and Bob registered to EERC contract. Registering means that they derived some encryption and decryption keys from their existing wallets, EVM wallets, and then they send a transaction to save them onto the contract. Now, let's say these two people have some balances on the contract, and Alice wants to send some funds, encrypted funds, to Bob. The thing is, when like Alice is doing that, she needs to generate his Romlush proof, which shows that the amount that she wants to send to Bob is greater than or smaller than or equal to his balance, right? While doing this, she basically puts her balance, current balance, as a public input to the circuit, so that when the contract verifies this proof, it checks whether the proven balance is the same one that is located in the contract currently, right? So the contract knows that she actually proven her most recent balance to the current balance. Mm-hmm. So what happens when Alice is generating this proof, right? Preparing the inputs, doing the encryption from her wallet. Charlie sends another transaction to Alice, which changes her ciphertext located in the blockchain. This basically invalidates the proof of Alice, which prevents her to, it basically locks Alice's balance. So to prevent this, we employ a strategy that we call balance list. It's basically, so we basically realize that the contract actually knows that even though the Alice's balance has changed, the balance that contract is currently has changed. It is still like the Alice's statement is still correct, right? Because the Alice just received something, so her balance must be still greater than the amount she wants to send. So the balance list basically instead of contract checking whether the proven balance is exactly the same as the current balance, we basically store the previous balances in that list, and contract checks whether that balance is included in that list, the proven balance. So this list is cleared when Alice performs some outgoing operation to someone else, right? Because at that point, the contract cannot know whether the next amount will be greater than the balance or not. So we clear the list and add the latest one on top, and this goes on. So this is one of the unique properties that we employ with the EERC. This is also super gas efficient compared to the other protocols that employ different strategies to prevent these similar issues.
What actually makes it more gas efficient?
So we are fully relying on existing, well-known, and like classical elliptic curve-based cryptography, which are like both efficient in terms of proving and also on-chain verification, and also the primitives we are using are super lightweight compared to the other protocols. So, for example, if you can write the same like EERC using something like fully homomorphic encryption, right? But it's like lattice-based, cryptography. It is like super incompatible with existing blockchain systems. So you need to have like some form of precompile, and like let alone precompile, the computation itself is also like heavy duty. You need to do maybe like bootstrappings, comparisons, etc. We're basically we don't use any of those. We just use basic primitives in a unique and smart ways to make the gas costs less, to simply put.
Yeah, I can add something here. Is actually the main reason the ERC is just this lightweight is because thanks to the zero knowledge proofs. So what we are actually happening is while you are transferring some encrypted tokens to someone else, you all do encryption, decryption operations locally and generate just a small proof of it. And we are just and the contract protocol will verify this proof while revealing the sensitive data of the user. So all of the computation done in off-chain and verified on-chain. This is why ERC is very lightweight.
Oh, okay. Thank you so much for that summation. That hit the nail on the head too. Um, and I know, Mehmet, that you had unmuted earlier. I think you had a little bit more that you wanted to add about Poseidon.
Yeah, yeah. Poseidon encryption is, like I said, is just a set of ciphertexts that we store for the users. Like my friend Furkan said, is decrypting the Elgamal ciphertext is requiring the solving the, like I said, discrete logarithm problem. Because of that, we are using different ciphertexts for decrypting and tracking users' balances in efficient way.
Ah, I see. And really quick, 'cause I know we talked about front running. Can we summarize what front running is, just for the folks out there who may not know what it is, and then explain why other protocols maybe had issues handling front running?
Yeah, the front running is so since ERC is encrypted with the user's public key, when user try to send it encrypted tokens to another user, they need to prove that they own that balance. And this is actually happening by you create a proof that I'm on that balance and send it to the contract, and contract will check the encrypted balance of the user and the state and the provided one. If this one is matched, and that means that okay, we are good to go because users can prove that they own the balance. But if I generate the proof for the ciphertext A, but in the meantime, Furkan can send me an encrypted token as well. And since the homomorphic property of the Elgamal ciphertext, which means when you add two ciphertexts together in Elgamal and you decrypt the resulting value is actually the sum of these two values as well in decrypted way. So this is the main problem of the front running that Furkan mentioned.
Ah, I see. Thank you so much, man. I love these kind of highly technical conversations, um, but definitely want to break it down as much as possible for the audience out there as I can. Can we talk a little bit about how ERC enables confidential we actually talked a little bit about that as well. Can we talk about um, how ERC is compatible with existing wallets and infrastructure, and then how can developers adopt it quickly?
Yeah, so I think that the exciting part about ERC and the fact that it's very lightweight, it's very easy to deploy on any EVM chain, makes it really attractive for any chain that wants to leverage it that is an EVM, right? So super beneficial for Avalanche. Obviously, we mostly deploy like subnet EVMs, and obviously can be used on C chain, but can even be extended outside of that ecosystem. To simplify the process for adopting EERC, we also developed SDK to simplify generating the proofs and handling the interactions with EERC, which makes it very convenient for any wallet provider to integrate EERC so that users can leverage confidential transfers within the wallet application. So and aside from that, it also benefits from the fact that there's no protocol level changes either, right? So a wallet can adopt EERC and using it without the underlying chain having to do any extra work aside from having the contract be deployed.
Oh, that's super huge. Okay, that's awesome. In what ways does ERC kind of address like regulatory concerns and compliance, specifically on like the enterprise side?
Yeah, so I think the unique thing here is that we have this auditor component. So I think, for Constar, to hit on this a little bit earlier, there's kind of a few different areas of privacy that you start to look at when you're building some of these solutions out, right? So there's confidentiality, which is the transaction balances and transaction amounts. There's anonymity, which is, hey, do I know the sender and receiver? Are those addresses obfuscated? And then there's auditability. What's our ability to decrypt the transactions, see what was going on under the hood? And then there's composability, which we can talk about a bit later. But I think the key component here is we added this auditor capability so that anyone who deploys this can easily decrypt the transactions, and particularly if they're a regulated entity, make those available for their local regulator. And I think it's interesting. I was talking with a project last night that is on-off ramp that is interested in using this, and one of the key selling propositions to them was the fact that, hey, we've got this auditor capability, right? Because they're already regulated by their local government, and they kind of say, hey, we want to keep things on the up and up, and now that we have this capability, we can have the confidential transactions, which is a huge benefit to their users, but then also they can still do what they need to do around regulatory reporting and things like that.
Has that kind of been like the major roadblock to kind of institutions kind of being brought into Web3 in general? Do you think, what are your thoughts on that specifically? Do you think that they just kind of, we can't get audited, unfortunately, but we also can't be public, so like
Yeah, I mean, on the institutional side, definitely auditability and is a major component, right? I think there's a whole other narrative that you can start to talk about, which is where things like Tornado Cash and like the more Web3 native community starts to intersect. But for institutions, auditability is critical, right? Like if you're a bank, if you're a financial institution, or if you're a money transmitter, right? Like you need to maintain those healthy relationships with your regulators. And I think kind of saying, hey, we've got this confidential blockchain tool that allows you to do private payments, it kind of brings about some questions. And so you want to make sure you're doing the right things. So it's kind of the, like from a product perspective, I think it's all about kind of the trade-offs and the risks, right? And this seems to be the right risk to benefit balance here on, hey, we can offer this great key selling proposition to our clients of confidentiality, but then also we can still do what we need to do to make sure we're maintaining a happy, healthy business that is operating in the right way.
I love this, man. I love that we're completely removing these barriers for institutions and enterprises, so that we can start seeing them start to file into the Web3 market, because there are a lot of huge benefits specifically for them here. Even just thinking specifically about Avalanche Octane that just came out, that's a huge benefit for any institution or enterprise that's sending payments or anything anywhere. So hats off to what you folks have built now. And of course, I got to squeeze you for a little bit of alpha as well, my friend. We got to talk a little bit about the future. Can you tell me a little bit about what are AvaCloud's next steps in expanding kind of this EERC ecosystem?
So I think EERC is kind of where we started. It is lightweight. It kind of addresses the two key components of the confidentiality and auditability. We're actually have another payment solution that we're working on that is available to be deployed specifically on an L1 that enables not only confidentiality and auditability, but also anonymity. So it's really specifically designed around payments, highly efficient P2P transfers. It can be leveraged for things like payroll, internal treasury management for, large organization that maybe has multiple lines of business, this sort of thing. So we're quite excited about that. And, there's, I think, going to be some large announcements in the next few weeks where we dig in even more on that one, which, Furkan and Mehmet here will be happy to dig into all the technicalities of that once we get there, because that's an even more fun one.
Yeah, that is absolutely major. I'm really, really excited about that one, and glad you gave us that little bit of alpha right there as well. And then also too, I wanted to ask you, how do you envision kind of the future of privacy preserving infrastructure across Web3?
So I think, Furkan and Mehmet jump in here. I think we're still early days, right? I think there's been a lot of movement, and we talk with other projects and other teams that are releasing privacy preserving applications that leverage different technologies, right? Like, I think today we've talked a lot about how we've leveraged zero knowledge proofs to enable some of these privacy solutions. On the flip side, there's other things that we're starting to experiment with, which if you check out the white paper that JPM Connexus put out, Project Epic, that covers a proof of concept that we built out that leverages a few different components, right? So it has zero knowledge proofs. It also uses distributed homomorphic encryption, which is kind of a blend of MPC and FHE, fully homomorphic encryption, and offered a lot of different benefits to that project, and kind of saw the potential of what you could start to do. And then there's other projects that are doing things specifically with like trusted execution environments, TEEs. So there's different ways of kind of cutting the pie here, whatever the right saying is. But it's exciting to see what's coming.
Yeah, I'm really excited too. I mean, the use cases seem really huge, and from what I've heard thus far, this is going to be extremely beneficial to a lot of folks that are in the enterprise and institutional sector, as well as just Web3 overall. And it's even going to touch payments, like staffing, the staffing sector as well. And I'm sure that there's other sectors that it's going to touch that we haven't mentioned today. So super excited for all of this and what you folks have built. Hats off to you. Hats off to you and the team, man. This is absolutely huge, man. And I just want to say thank you. Um, we're coming up a little bit close to time here, and I want to make sure that that anyone who's been listening to this and is kind of interested in, you know, getting started with you folks, where can they kind of, get started if they're kind of interested in ERC and AvaCloud specifically?
So we have a documentation for all of the products, for ERC product, and for the interaction for it for the SDK as well. So they can find a detailed explanation of the protocol. In addition to that, actually, I have developed a tool that actually explore what ERC is, what is they capable of, and the little bit explanation what is the encryption schemes for it. And I will post it from here as well. Just staying tuned for the updates too.
Man, you got it, Will.
And then on the AvaCloud side, obviously, you can head over to AvaCloud. You can deploy your L1. I think testnet takes you like 15 minutes, soup to nuts these days. And then once that's up, we have a free trial that'll run for 5 days, and you can go ahead and deploy EERC on your L1. So all of that is in AvaCloud. Easy deployment. You've got a management console, so you can mint and burn assets and do transfers right from the portal.
And for everyone out there who's checking this out and wants more information on AvaCloud, wants to stay up to date, don't worry, I got you. Right down there at the bottom, my friends, make sure you follow at AvaCloud, AVA Cloud, and follow AVAX as well, my friends. They have built something that is absolutely huge, and they are continuing to build more huge things. They're going to be absolutely revolutionary and change kind of the landscape of Web3 staffing and an institution. They're just changing things, my friend. So you want to make sure you stay up to date. I'm going to give you a pro tip on how to make sure you stay up to date. You're going to follow AvaCloud, and then you're going to hit the bell notifications, my friend. You're going to hit bell notifications. That'll make sure you get notified every single time these folks post, so you can stay up to date, my friends. I want to thank my audience so much. Thank y'all so much for popping on today. If you just kind of tuning in, don't worry, my friends. I'm going to get this up on Spotify ASAP within the next 24 hours. So you can check it out on there if you missed anything on your ride back home from work or your ride to work. But I'm going to end this thing really quick just by simply saying peace, my friends. And